So we'll be starting with calculus maxima and minima. So if you are given any function like f of x, okay, and you need to check its maximum and the minimum value. So what you need to do, you need to do any point first you have to identify. Okay, let there be any point a and b. Okay, this is the interval a and b. You are substitute. No, if it is only for one variable, then there would be only one point a. Okay, so if you check f dash of a is equal to 0 and the second derivative of this point is equal to is lesser than 0, okay, then this will give you the maximum value. Now in this case this will give you the local maximum, not the global maximum value, local maximum value. Okay, local maxima. Okay, I'll explain you what is local maxima and global maxima. Same way, if you are doing f dash of a and it is coming around 0 and f double dash of a is greater than 0, then it will give you the minimum value. Now, if you are having an equation which is having two variables, then how to find is, first of all, you need to identify the points x comma y, okay, such that your f of x is equal to 0 and f of y is equal to 0. What is f of x? F of x, there would be the first derivative of the function, right? F of x, if we write, it would be the first derivative of the function. So this would be, let's say this would be f of a, d by dx of f of a, or f of x function only, and f of y would be equal to d by dy of f of y. Okay. So, and then then you associate some numbers a is equal to f of xx, which would be a second derivative of d square by dx of f of x, and f of xy you can get as d by dx of either f of y or the partial differentiation with respect to f of x, wherein f of x you already have the first derivative of your function x function, okay, and f of yy is the double derivative of f of y. So now, how to compute basically here? Here you have to check, see, you have to identify any point, stationary point, x naught and y naught is a maximum point if your AC minus B square is greater than 0 and A value is less than 0. A value less than 0, maximum value. A value greater than 0, minimum value, and this condition should be satisfied. If your AC minus B square value is not equal to 0, right? Or AC minus B square value happens to be equal to 0 and A equals to, then overlook such cases. These points are called as saddle points. Okay, now let me take an example. Here, one simple example I have taken. A function is given x cube plus 3xy square minus 3x square minus 3y square plus 4. Now I need to find the maxima and the minimum value. First, what I do is, for this function f of x I have to do, so I have to take d by dx of f of xy. So if I do d by dx of f of xy, this is my f of xy function. So I derivate it, x cube ka I will get 3x square for 3xy square. Okay, here x will go, so 3 by square remaining. For minus 3x square, it will come as minus 6x. And this is with respect to x, so this will become 0. And this is a constant value, it will become 0. So I got dxy function like 3x square plus 3y square minus 6x is equal to 0. Okay, this was my first function. Then f of y would be d by dy of this. So again, I do the same thing with respect to, so x cube point will become 0, right? This will become 6xy, x square is 0, and this will become 6y because y square ka differentiation is 2y. So minus 3 into 2y is minus 6y, and 4 again it will become 0. So now, see, now I have these two functions here. So if I take 6y common, 6y into x minus 1 is equal to 0. So what does this mean? 0 by 6 would be 0. So y is equal to 0 and x is equal to 1. Okay. So the stationary points that I'm going to get here, this condition will happen if my y is equal to 0, right? And x is equal to 0, one of the points I got. Now, if my y happens to, see, this is my x and this is my y point, right? If my x happens to be 2, okay, then to satisfy this equation, the second equation, what are the conditions? Either this x is equal to 2, 2 minus 1 into 0, okay, or y is equal to 1, x is equal to 1. Again, I get 0, 0 value there, right? This equation number 2 is getting satisfied. Or y is equal to 1, sorry, x is equal to 1. So 1 minus 0 and y is equal to minus 1 and 0. So these are my 4 points. So I will take these 4 points and arrange in a table. So this is my table. Basically, this is my A. A value was my d by dx of f of x. which is nothing but d by dx of 3x square plus 3y square minus f of, because this is my a is my f of xx, right? B is my f of yy. B is not my f of yy, it is f of x comma y. Okay, the first derivative. It can be either d by dy of f of x, right? If I take the f of x function there, so I do d by dy of 3x square plus 3y square minus 6x. So if I'm doing with respect to y, so this becomes 0. Okay, this becomes 0. So I get 6y. If I do it with respect to d by dx of f of y function, f of y function, if you go previously, it came as 6xy minus 6y. So if I do with respect to this, so this 6y will not happen. X gets cancelled, so it will be again 6y. Okay. So this is my function. And differentiation d by dy of f of y would be, f of y function was 6xy minus 6y. So if I differentiate it, so it will remain 6x minus 6. Now, maximum value will appear when AC minus B square happens to be greater than 0 and A is less than 0. And minimum value AC minus B square will be greater than 0 and A is less than 0. So if I just put the points 6x minus 6, 6y, okay, 6x minus 6. Now I have to do AC. I just put these points 0, 0. Okay, when I put the 0 point here, so I get the value of this A as minus 6, which is less than 0. So it happens to be one of the conditions for, okay, I have to simultaneously check what about my AC minus B square, right? So at this point, you see B value is 0 because I'm putting the Y value 0, and C value happens to be because I'm putting the X value 0 minus 6. So if I do AC, I A and into C, I get minus 6 into minus 6, 36. 36 is greater than 0. So one of the conditions is satisfied. One is your A value is less than 0 and AC minus B square is greater than 0. So this happens to be my maximum point over here. Okay. So that means 0, 0 is the maximum point there. Okay. So if I substitute in this equation the value of x as 0 and value of y as 0, I'll get the maximum point in the main equation. Now, if you check for this 2 comma 0 value, so here x value is 12 minus 6. So this is 6, which is greater than 0. And here the second value is 0. So it happens to be 0. And again, here it is 12 minus 6, which is positive, right? So if A is AC minus B square is greater than 0 and A is positive, then what you get? Minimum point. Any other point other than that, any other point. Now here you see AC minus B square is minus 36, okay, which is not a correct point. We have to ignore that point, right? So here I had mentioned in the previous thing, AC minus B square, if it is less than 0, if it is negative, ignore it. Okay, if it is equal to 0, you need to ignore it. If A value is equal, so this is, these points are called saddle points. Similarly, if you check for the other conditions also, this would be your saddle point. So your maximum point happens to be 0, 0, and minimum point happens to be 2, 0. So in the main equation, if you are going to substitute 0, 0, this was your equation. 0 for this, 0 for y, and this for 0. So your maximum point of f of x comma y will come as 4. Correct. And the minimum point happens where, you just check, the minimum point happens at 2 comma 0. So that means x value you have to put 2 and y value you have to put 0, right? So this becomes 0. X value you have to put this becomes 0. So this will be 2 cube minus 3 into 4 plus 4. So this would be 8 minus 12, which is nothing but 8 minus 12 is minus 4 plus 4. So your minimum point is 0 over there, right? So this is the explanation for the maxima and minima. Now let's go to the gate examination questions, how they are attacking this type of a scenario. Now see here, one question has been given, this has been asked for 2 marks. Okay. Now 3x cube minus 7x square plus 5x plus 6. And the range of the values, the points they have given from there itself. So 0 and 2. Now, if you put the value of this as, this is only function for x. So if you put the value 0 for x, so it will become 0, 0, 0. So the remaining value here is 6, right? But this is, see, how to identify the minima point? In closed interval problems, endpoints don't follow, basically that they don't follow the comparison rules. Okay. As far as the second derivative is concerned, it will only give you the global behavior, whereas the endpoints will give you the global decision, like the global maximum. Now, In order to understand this problem, suppose you are climbing a hill, there is a small peak inside the hill. Okay. Look, but the road ends at a higher cliff. When it is ending, the end point is 2, it is ending. The cliff does not need a flat top, zero slopes. Okay, it just needs to be higher. So in order to get the maxima point from over here, what you do is you just directly substitute the value of the endpoint. Your f of 0 value happens to be equal to 6, right? And f of 2 value, if you just compare there, 3 into 8 minus 7 into 4 plus 5 into 2 is 10, 10 plus 6. So this will give you 24 and 16, right? 20, which is nothing but 40. 40 minus 28 is equal to your 12, right? This is your 12 point. Okay. So this is how this problem has to be done. It's for 2 marks, but directly if you substitute the endpoints, you'll get the result for this. Okay. Now let's identify one more maximum minima value problem. I have not taken over here. Okay. So I'll do in the next. Okay. Question number two was this. Question number one. Let's move to the question number one. Okay. Okay. One more question has been asked. Put over here. Okay. Here it is. Okay. So f of xy is equal to, okay, here one question. See, this has been asked in the gate examination. Y is equal to 3x square plus 3x plus 1. Maxima and minima values for minus 2 comma 0, right? So for 0, if you put the minima value, okay, so what is the value you are going to get? 1. Okay, maximum value. So here, derivative, do you need to take or not in this scenario? Okay. So the maximum point you will get by minus 2, right? And the minima point, how do you get? If you take this first derivative of this f dash of y, right, and equate it to 0. So what you will get? 3 into 2x plus 3 is equal to 0, right? This will become your 6x plus 3 equals to 0. So your x happens to be equal to minus 3 by 6, right? So this is your minus 1 by 2, right? So the a value here is less than 0. So this is satisfactory. And now you substitute this point back there. So this would be 3 into minus 1 by 2 ka whole square plus 3 by 2. Okay, 3 into minus 1 by 2 plus 1. So this would be 3 by 4. Okay, minus 3 by 2 plus 1. Okay, take this derivative here, 8, right? So 2 into 3 is 6, 6, and then minus 3 into 2, right? For this 4 wala value. So you just multiply this here, and here 8. So 8 minus 12, 6 minus 12, and 8. So this will come as minus 6 plus 8 by 8. So this will come as 12 by 8. Okay. So you can calculate not 12 by 8, 2 by 8, right? Because this will be your minus 6 plus 8 is 2. So this would be 1 by 4. So so the minima value is 1 by 4, right? Minima value you have to do the derivative technique. Maxima value just substitute the end point. The end point is x of minus 2. So minus 2 if you substitute there. So 3x square, the problem is saying, where is it? Yeah. So the problem is saying 3x square plus 3x plus 1, right? 3x square plus 3x plus 1. So the endpoint is minus 2. So is it 3x square or 3x cube? Yeah, it is 3x square. Correct. So you just put the value minus 2 there. So this would be 3 minus 2 ka whole square plus 3 into minus 2 plus 1. So this from here you will get the maximum value. 3 into 4 minus 6 plus 1. So this would be 12 minus 6 plus 1, which would be 6 plus 1, 7. Please make sure that you are take care of the board mass. Okay. So here the max value is 7 and minimum value is equal to 1 by 4. Now, similar to these questions, there is a question like maximum minima questions. They ask these questions. Which of the following is true for all possible non-zero choices of m and n when m is not equal to n, or possible non-zero choices for p and q when p is not equal to n? Okay. Now here very important understanding for this particular question is that, see, you need not to solve this. Okay. So here you just have to check. Sine function is an odd function, cos function is an even function. Okay. If you are just doing a product of odd and even, you will get an odd function. So this is your product, okay, and this is your result. Product of odd into odd is even, okay, this is the result, okay, and product even and even will give you even always. Odd into even will give you odd. Now you have to remember this for limits, like if these are symmetry limits, the product, the integration of an odd function integral will give you 0. Like for example, if you have minus a to a any function sine, okay, x into sine y, okay. So now you see this is what? An odd function, okay. This is what? An odd function. So now if the result is an odd function, now odd and odd is what? An even function, right? Now this resulted into your even function. So even function will not give you the value 0 for symmetry. This will give you twice a comma 0. Okay, f of x dx. Okay. If it was an odd function like minus a sine x, let's say cos y, then you will get a function 0. Okay, because you will get an odd function. Now, which is the function? Now here you see, first of all, you have to see which is your result is odd, right? So here also you see the result is even. Okay. Here also you see the result is odd into odd. Na? This is even. Again, this is even. So only the function where you are getting odd into even, which will result into an odd function, is this. So you see this, and also you check the symmetry, pi and minus pi. So the symmetry is there. So this is resulting into 0. So you have to check the symmetry. So only the correct answer for this would be B. Okay. So let me just stop this.